section 9.1, sequences. Anybody know what a sequence is?
I don't know what sequences are for genetics.
What are sequences for genetics?
Like if we have an A sequence, it's just a whole bunch of A's.
What if you
Or
have?
like for codes, those are sequences, the 3-base code for stuff.
So give me an example of a 3-base code.
Like ACU is like a codon for a specific protein.
Okay.
It's a sequence of 3.
So it's 3 things that repeat over and over and over again. Okay. What's a sequence in math?
Probably the same thing.
It's the same thing. In math, a sequence is a function with domain positive integers. So you might see something like f at 1 equals 1, f at 2 equals a half, f of 3 is a third, f of 4 is a fourth, f of 5 is a fifth, and I could go on and on and on forever, right? That would be a sequence. Now, typically when we deal with sequences, we don't write them using function notation. And I'm sure in chemistry you don't write sequences using function notation like that. Typically we write a sub 1 is 1, a sub 2 is 1/2, a sub 3 is a third, a sub 4 is a quarter, so on and so forth. Or even more generally, we just give a formula. We might write a sub n is 1 over n. So that's how we generally write sequences in math. Questions on that? All right, the big question for us that we're going to want to know is we're going to want to know if our sequence converges or diverges. What do we mean by converges or diverges? Does it have an asymptote or does it not have an asymptote? We say a sub n converges if the limit as n goes to infinity of a sub n equals some number L. So when you said we're looking for an asymptote, that's exactly correct. We say a sub n converges if it has a horizontal asymptote. That was exactly correct.
Only horizontal?
Only horizontal. Because n is our x values,
Okay.
so a sub n is our y value. So we're looking for a horizontal asymptote, not a vertical asymptote in this case. L is referring to, I used L for limit. So L is your horizontal asymptote. L is the number that it gets close to. So, for example, this is an easy one. What's the limit as n goes to infinity of our sequence a sub n, which was 1 over n? That would be 0. So does that sequence converge?
Yeah.
Yes, in fact it converges to 0. So we would say a sub n equals 1 over n converges to 0. How about the limit as n goes to infinity of 2 to the n over n squared? It's infinity?
Infinity over infinity.
It's infinity over infinity, which might be infinity, might be 6. Which is it? 1.
That's infinity. So
But it's
that's
infinity over infinity. Yeah, it's not 6 over 6. 6 over 6 would be 1. Infinity over infinity can be anything. That's one of our indeterminate forms. How did we find limits when we had indeterminate forms of infinity over infinity? We used L'Hopital's rule. I do think you're right. The correct answer is infinity. This is the limit as n goes to infinity. I'll take the derivative of the bottom. The derivative of the bottom is 2n. How about the derivative of the top? This goes way back to chapter 5.
Something over ln2, right?
Nope.
I
You're
don't
close though. It's got an ln2 in it.
Yeah. That's all I know. So ln of the base.
So what if this were an e? How do you take the derivative of e to the n?
Bring the n down.
Derivative m times
What's the derivative of e to the x?
E to the x.
E to the x. What's the derivative of e to the n?
E to the n.
E to the n. But this is not an e, this is a 2. The derivative of 2 to the n is 2 to the n, ln2. Division is when you integrate. When you integrate, you divide by ln2.
That's
When you differentiate, you multiply by ln2. That's still in the form infinity over infinity. So what do? I do it again. This is the limit as n goes to infinity. What's the derivative of 2 to the n?
I'm sorry, 2.
2 to the n, ln2, but I've already got an ln2. So ln2 times ln2 is ln2 squared, which is different from ln4. Divided by 2. Now we're in the form infinity over a number. That's infinity. So this is a divergent sequence.
Would the top of... Oh, never mind. Sorry, I thought it was product rule, but it's not.
It's not product rule because ln2 is
Yeah.
just a number. Yep. Same question. ln2 is just a number, so I don't need product rule. So we would say b sub n, which is the sequence 2 to the n over n squared, is divergent. How about the sequence c sub n, which is 4 plus negative 1 to the n?
So this n always moved over infinity.
And for sequences, we're always looking at what happens when n goes to infinity. That's correct. So there's only ever one limit you need to compute. The limit as n goes to infinity.
but this n number is going to be positive. Those are odd numbers.
So what you're saying is, if I were to write this sequence out, this sequence is, if n is 1, I get 4 minus 1, that's 3. But if n is 2, I get 4 plus 1, which is 5. If n is 3, I get 3. And then the next one is 5, 3, 5, 3, 5, dot, 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 goes forever. Is that converging?
It's oscillating between the two.
When n goes to infinity, is that getting close to a number?
No.
No, it's jumping back between
5.
3 and 5 or 5 and 3, depending on which way you want to say it. So what would we say about that sequence? Not indeterminate. Our question is, does it diverge or does it converge? It diverges. It does not converge. The sequence is divergent. C sub n is divergent.
What would that graph look like?
What would the graph look like? I would have the point 1 comma 3, 2 comma 5, 3 comma 3, 4 comma 5. The graph would look like that. It would just bounce back and forth. And remember, when we're dealing with sequences, we're dealing with just distinct points. You would not connect the dots here. Because when we're dealing with sequences, we don't plug in a number like n equals a half or n equals 3 halves. We only plug in 1, we plug in 2, we plug in 3, we plug in 4. So these graphs are going to be graphs of distinct points, not connected curves, so it doesn't look like some sort of wave. It's just dots bouncing up and down. n can only be an integer. In fact, n can only be a positive integer. So I can't use 0, I can't use -1, I can't use -2, I can't use any fraction, can't use any decimal. I only get to use the real nice numbers, the ones that I like a lot. 1, 2, 3, 4, 5, so on and so forth. Questions on that?
How do these get hard?
Yeah.
How do they get hard?
Mhm.
Oh, I don't know.
I'm curious. I'm sorry, you know what?
Haven't you heard curious?
Well, I'm gonna die very interesting lifetime.
Yeah, it's not-
So you're gonna say good thing I'm not a cat.
He was the other way on that one.
All right, well, the way these get somewhat harder, I suppose. What about factorials? We haven't dealt much with factorials in calculus at all. What does factorial mean again?
You add
Not add them,
Multiply.
multiply them. For example, 4 factorial
4 times 3 times 2 times
means 4 times 3 times 2 times 1, which is 24. How do you do it with a variable? Well, 6 factorial, just for example,
Really big.
would be that, whichever that is.
But there's a way to do it in your calculator.
There is a way to do it in your calculator. 6. I think it's under the math button. Under probability.
Oh, there it is.
720. Okay, so what's going to happen when n gets bigger and bigger? When n gets bigger and bigger, what's going to happen to n factorial? It's going to get bigger. In fact, it gets big pretty fast, doesn't it? 6 factorial, you're already up to 720. 7 factorial would take 720 multiplied by 7. You're already into the almost 5,000 range. Okay? So this is in the form infinity over infinity. The problem is we don't have a derivative rule for factorials, so I can't use L'Hopital's rule. I don't know how to take the derivative of n factorial. So what do you do? Can you cancel? Absolutely you can cancel. This is the limit as n goes to infinity. What does n factorial mean to do? You take 1 times 2 times 3 all the way up until you get to n, whatever number n is. So this is 1 times 2 times 3 times 4, and I stop when I get to n. What does n plus 2 factorial mean?
N
I think we just stopped at n plus
2 times 2 so on and so
I go 1 times 2 times 3 times 4, and I stop when I get to
forth.
n plus 2. So this is going to be 1 times 2 times 3 times 4. Oops, n plus 2. So as you can see, a whole bunch of stuff's going to cancel out, isn't it? The 1's cancel out, the 2's cancel out, the 3's cancel out.
Except for n over n plus 2.
Close.
It's just n over n plus 2.
What comes right before n plus 2?
N plus
n plus 1. What comes right before n plus 1?
n.
n. So what cancels out?
The n's.
Everything, the 1's, the 2's, the 3's, the 4's, all the way up to n. So we're left with limit as n goes to infinity of 1 over n plus 1 times n plus 2. And you're right, you're in the form 1 over infinity, so 1 over infinity as a limit is 0. So those factorial problems are a little weird at first.
So you
Takes a little practice to get used to those.
should almost always get, use that signal back on top.
Yes. Well, depends on what you have on bottom. If I had n factorial up on top, but I had n minus 2 factorial down on bottom, then I'm going to have more on top than I do on bottom. Because if I had n factorial divided by n minus 2 factorial, this would be 1 times 2 times 3. I stop at n. Or this one down on bottom would be 1 times 2 times 3. stop at n minus 2. But then you got to think about what's going to cancel. Well, the 1s, the 2s, the 3s obviously cancel out. When do I stop canceling? At n minus 2, because n is bigger than n minus 2. So right before the n comes an n minus 1, and right before that comes an n minus 2. So this one would be a divergent sequence. The top is bigger than the bottom. That would be a divergent sequence. That would be infinity over 1, which would be infinity. It would be divergent.
Is there a sign for multiplication, like the sigma notation?
Yes. So if I wanted the sum from I equals 1 to n, we wrote it that way. If I want to multiply 1 times 2 times 3 times 4 times 5, I can write it, of course, as factorials, but we also use this symbol. Oops. So we use a big Greek letter P, or pi for product. So n factorial could be written that way. If I wanted to take 1 squared times 2 squared times 3 squared up to n squared, I would write it as the product from I equals 1 to n of I squared. So there is a symbol for multiply a whole bunch of things together also, just like there was a symbol for add a whole bunch of things together. Other questions? I don't think that symbol shows up anywhere in your book, but there is such a thing. All right, what else do they have in this section? Oh, some trig functions? What a wonderful idea. How about the limit as n goes to infinity of sine n over n? Converge or diverge? I heard a vote for diverge, I heard a vote for converge. One of you is right, one of you is wrong. Sine is stuck between 1 and negative 1 with no asymptotes.
So
It would be approaching 0
Why?
because the bottom would keep getting bigger and the top would still be small.
The top's going to be stuck between negative 1 and positive 1, while the bottom's going to keep getting bigger and bigger and bigger. We use one of our old favorite theorems from Calc 1. Anybody remember that theorem that I just used? This is called the squeeze theorem. Sine n over n can be squeezed between negative 1 over n and positive 1 over n, because the biggest possible value for sine is 1, the smallest possible value for sine is negative 1. As n goes to infinity, 1 over n goes to 0, and as n goes to infinity, negative 1 over n goes to 0. So since this thing is squeezed in the middle, it goes to 0. So that's a squeeze theorem. That one is convergent. It converges to 0.
So tan would be divergent.
As n goes to infinity, yes. Because tan isn't bounded between negative 1 and positive 1. It has vertical asymptotes. What if I just had the sine function all by itself? Convergent or divergent?
Be divergent, so just keep jumping.
It would be divergent because it keeps jumping up and down between negative 1 and positive 1. So it's divergent. Okay. Oh, you'll see a couple problems like this. 8, 13, 18, 23, 28. two things, two directions that they ask. Direction number 1, find the next 3 terms. And then direction number 2, write a pattern for the terms. So what's the next term?
33, 38, 43.
And how are you getting those?
It's adding 5 every time.
It's add 5 each time. That's correct. And then they want you to write a pattern. So they want a sub n equals
Base of
8 plus 5 times n minus 1. And a lot of people would put 8 plus 5 times n. But you're right, it is n minus 1. Why do you need the n minus 1? So your first one, remember the first number you're always going to plug in is n equals 1. Remember, we only use the positive numbers. We don't plug in 0. In computer programming, you always start at 0. In math, we always start at 1. So if I plug in 1, I need to get just the number 8. So I do have to have that little n minus 1 there.
Could you write another one that was a sub n equals 3 plus 5n? Would that work?
I think that would also work. I think another correct answer would be b sub n equals 3 plus 5n. Because when I plug in 1, I would get 8. When I plug in 2, I would get 13. Yes, that would work. Absolutely. Another correct answer. Other questions? One time, many years ago, I was at a conference, and the speaker gave a sequence. He put something like 28, I don't remember what his numbers were, 63, 101, and challenged people to give the next 3 numbers in the sequence. And so, being a classroom full of math teachers, what did we do?
Start crunching numbers.
We started crunching numbers. So people weren't paying attention to his talk. They were sitting there crunching numbers, trying to figure out the pattern. At the end of the talk, he gave us the answer. And the answer was, when I left home this morning, I started on Highway 28, then I went to Highway 63, then I went to Route 101, and it was the road numbers he had driven in on. People were very angry with him. This just goes to show that sequences don't necessarily have to have a distinct pattern. In this class, sequences will generally always have a distinct pattern, and you'll be able to write it down, but they don't have to be a list of random numbers, and that's what he did to us.